This is lesson 4.7, piecewise function. The essential question here is how can you describe a function that is represented by more than one equation? Our core concept here is what is a piecewise function? It's kind of like what it sounds like. A piecewise function is a function defined by two or more equations. Each piece of the function applies to a different part of its domain. An example is shown below. Like if we have f of x is equal to x minus 2, but that's only true for x is less than or equal to 0. And then for the part that x is greater than 0, we're going to use the function of f of x equals 2x plus 1. So see how these two parts or pieces of the function are both graphed on the same graph. So example 1 here is wanting us to evaluate a piecewise function. So just evaluate the function that we just used in that core example there. Evaluate that function when x equals 0 and when x equals 4. So for at x equals 0, we got to decide which one we're going to use. At x equals 0, we're going to be using that first f of x. F of x equal to x minus 2. Because see, that's when it's x is less than or equal to 0. And since we're going to use 0, that's part of this. So f of 0 is 0 minus 2. Or f of 0 is negative 2. Now it's asking us here also to define it for part B. So this is A, here's B. When x equals 4. When x equals 4, well that's greater than 0, so we're going to be using the function f of x equals 2x plus 1. Because see, 4 is going to be that greater than 0, so that means we use this function. So f of 4 would be 2 times 4 plus 1, or just simply to simplify that, you got 8 plus 1, or 9. So f of 4 is 9. So now looking at example 2 here, graphing a piecewise function. It says here, for x is less than 0, we're going to use the first equation, y equals negative x minus 4. If x is greater than or equal to 0, we're going to use y equals x. So the first part I'm going to graph here is this negative x minus 4. And that's only if x is less than 0. So what if it cannot be equal to 0? But let's look here. We have a slope of negative 1, and it crosses the y-axis at negative 4. But the thing you got to remember about this at negative 4 is it can't actually be equal to it. So we're going to put an open circle at negative 4. And then with a slope of negative 1 here, the line would look like this. But remember, we've got that open circle at 0 because it's not true at 0. But now for the other part, it's true at f of x equals 0. So our starting point's at 0. And then we just graph our line right here at y equals x. And that's going to be the part of that function. That's how you would graph this piecewise function. So let's look at our third example here. How about writing a piecewise function? To write a piecewise function for the graph that's given. Well, each piece of the function is linear. Our left piece here is when x is less than 0. So at x is less than 0, what is that function? Well, it's the graph of the line. Let's see. We have y equals, we know our slope is a positive one, so we can just do x, and then our y-intercept would have been at 3, so we'll do x plus 3. So for x is less than 0, we're going to use y equals x plus 3. Now what about the right part of the equation? This is for x is greater than or equal to 0. Well, again, we're just going to write that equation. Y equals, what's my slope? A rise of 2, run of 1. So we've got 2x, and it crosses the y-axis at negative 1. So minus 1. So our piecewise function, if we were just to write it all together, we would put f of x equals, we're going to use this bracket here, it's going to be x plus 3 or 2x minus 1. And this one's if x is less than 0. And this one is if x is greater than or equal to 0. It's just writing an equation. It's just telling us we just got to add on that end part of what is our limit. When is this function applicable? So what about graphing and writing step functions? A step function is a piecewise function defined by constant value over each part of its domain. The graph of a step function consists of a series of line segments. And notice that we have an open circle and then a closed circle. Because you can't have two closed circles, because then it wouldn't be true, because you would have two different answers. It wouldn't be a function. These still have to follow your function rules. Remember your vertical line test we talked about a while ago? A vertical line test, you have to be able to draw a vertical line anywhere, and it only crosses one point. Now the thing you've got to remember is, even though, like, if I go right on it, I would cross the solid point and the circle, but the point is that, remember, the open circle is not a value. So, graphing and writing a step function here. Let's say you rent a karaoke machine for 5 days. The rental company charges $50 for the first day, $25 for each additional day. Write a graph, a step function that represents the relationship between the number X of days and the total cost Y in dollars of renting the karaoke machine. So for 0 to equal to 1, it's going to be $50 because that's our first day. And for each day after that, it's $25 more. So if you're greater than a day, but less than or equal to 2 days, it'll be $75. Greater than 2 days, but less than or equal to 3, it's going to be $100. And it's going to continue like that. I could write it in a table here, or I could write it as our function. At 50, it's at 50 between 0 and 1. It's at 75 from 1 to 2. 100 from 2 to 3. So to graph that, we're just going to have our open circle on 50, then our closed circle on 1. Then step up to the 75, open circle, closed circle on 2. Open circle again on 2 at 100, then closed circle. And we're just going to continue like that when we're graphing this step function. Because if I rent it for a day and a half, I don't get a day and a half fee. They just charge me for 2 days. So whether I rent it for an hour, 1 day and 1 hour, or 2 days, I'm going to pay that same amount, that $75. That's why this is a step function. Now, what about writing absolute value functions? The absolute value function, f of x equals the absolute value of x, can be written as a piecewise function. If you notice, when we were graphing with Clever, it kind of made us do that. It made us graph one line, and then it made us graph the other line. So that's, you kind of already been starting this. So it also shows on here the vertex form of an absolute value function. this whole a times the absolute value of x minus h plus k can be written as a piecewise function, the same as just the regular absolute value can be. So let's look at an example here. In holography, light was from a laser beam is split into two beams, a reference beam and an object beam. A light from the object beam reflects off of an object and is recombined with the reference beam to form images on film that can be used to form three-dimensional figure. We're going to write an absolute value function that represents the path of the reference beam. The vertex of the path of the reference beam is 5, 8 here. So the function has the form g of x equals a times x minus 5 plus 8. This is just plugging them into that formula we had. We're just going to substitute the coordinates of the point 0, 0 into the equation. That way we can figure out what our a is. Because if you notice, we can see that 0, 0 is in that equation. So we're going to have 0 equal to a times the absolute value of 0 minus 5 plus 8. Well, 0 equals a times 0 minus 5 is a negative 5. So I'll just write that as negative 5a plus 8. So then I'm going to subtract 8 and divide by negative 5. So I'll get negative 5 equals negative 8, then divide by negative 5. And I'm going to get that a equals, a negative 1.6. This actually should have been a positive because it was an absolute value. That's why it's negative 1.6. So the function is going to be g of x equal to negative 1.6 times the absolute value of x minus 5 plus 8. This is just plugging these numbers into this absolute value formula that was given to us. So now what about part B? It's asking us to write the function in part A, which was, so we're going to write this as a piecewise function. So I'm going to have my g of x is going to equal negative 1.6 times the negative value of x minus 5 plus 8, and that's going to be if x minus 5 is less than 0, or it will be negative 1.6 times the positive value of x minus 5 plus 8 if x minus 5 is greater than or equal to 0. This is just writing it as a piecewise function. I know that might look a little more complicated, but that's just to show you that we've got the two different ones. But if we wanted to be able to simplify this, we could. If we simplified this, we could have g of x. Hopefully I can fit this on here. We just simplify, distribute, and combine like terms would be 1.6 x if x is less than 5, or it would be negative 1.6 x plus 16. Remember, there's a negative there. If x is greater than or equal to 5. Go ahead and show me your notes and then get started on your clever.